is one of the greatest detective stories of our time. How did it all begin? With, of course, the it referring to life. And life isn't where this story begins. It begins with all of this complex chemical evolution, which took, from our point of view, an extraordinary amount of time to finally reach life, after which, of course, life has its own complex evolution. Now, from my point of view, from political science, from those of us who come out of the social sciences and the humanities, the liberal arts, what does this conference have to teach us? And I think, as you'll see, it has to teach us a very great deal. And so that's why I really appreciate being a part of this effort. And the conversation between the natural scientists and those who are interested in humanity and in the liberal arts, that conversation has been going on for a long time. This is nothing new. And there's been, I think, a rich interaction for a long time. We can start, for example, with the example of Joseph Priestley back in the 18th century. He was an English chemist, a natural philosopher. He's historically credited with the discovery of oxygen, since he isolated it in its gaseous state. He invented carbonated water, and where would we be without that? He wrote extensively on electricity, on energy. He was a member of the Royal Society of London for the improving of natural knowledge. So he was interested in a full range of scientific issues, and that's where he became well acquainted and developed a friendship with Benjamin Franklin. Now, I might mention my university is right next door to Philadelphia, which itself is right between New York City and Washington, D.C. in the state of Pennsylvania. And Benjamin Franklin is our kind of our local hero. And it's not surprising that when Franklin was not carrying out his functions in England, representing various people here in Pennsylvania to the English government of the time, he was engaged in the types of pursuits that brought him into contact with Joseph Priestley. And so Priestley and Franklin struck up this friendship. And so it really isn't surprising as a result then that Joseph Priestley dedicated this work here, this new chart of history, to his friend Benjamin Franklin. What's interesting to me here is that Priestley, a natural scientist, is also clearly interested in history and in politics and in having friendship with diplomats from other countries. And that his new chart of history is looking at what he's got evidence for to talk about the past. He too was asking, how did it all begin? But he could only ask it in relationship to what he has evidence for. And what he's got evidence for are the history of nations and empires. So his new chart of history, it goes to the ancient Mesopotamian empires, the Persian Empire, and then the Roman Empire, and then the medieval period. He doesn't use the word evolution, but it's clearly the idea of progression over time. After the medieval period, he talks about the early modern and national periods with the national histories of England and France and Germany and Turkey and China and others. So this is his chart of history. And the it that begins for him are these nations and empires over time. And he has conversations that are so pleasing to him that he dedicates this to his friend Benjamin Franklin. Franklin shares his interests in electricity and energy. In 1749, he used the term battery to describe a set of link capacitors for his experiments with electricity. He's very interested in storing electricity. He's icon here in the Philadelphia region for his experiments on electricity, including this one that inspired this painting by Benjamin West of him carrying out his experiments experiment to see if lightning was in fact a form of electricity and of energy. And you know, and he must be an important figure because he's got these cherubs in the background helping him out with his experiment. I would like to call your attention to the cherubs on our left of Franklin. These couple of cherubs are huddling around a model of the celestial sphere. They are modeling the experiment that he is carrying out there in reality. And that idea of having the model of the celestial sphere was similar to other models, even more extensive models. This is a model of the solar system from the 18th century. It is now at the University of Pennsylvania. The University of Pennsylvania is a descendant of Franklin's idea of having a public academy of Philadelphia, whose purpose, he said, it was to prepare students for lives of business and public service, both of which required the application of reason and science. And this model of the solar system, which is now on display at the University of Pennsylvania, of course, these types of models were pretty common at the time, and they all have a mechanical view of the universe, of the solar system. It's a series of gears that they construct these models with. And then, of course, they have springs, and it's this big question of matter and energy, the stuff, and then what moves that stuff, and its structure and its movement, its matter and its energy that's of common interest to everyone. Time itself is thought of in mechanical terms, the watches of the time, all these very finely tuned gears, and then you wind it up and the springs move it so it performs a function, so we know what time it is. But this is a common part of the scientific dialogue that both Priestley and Franklin were interested in at the time. And it's these ideas that Franklin brings back to the colonies, to Pennsylvania, once the English colonies here in North America start talking about forming a new type of regime. So here we have Franklin at the Constitutional Convention. He's the fellow sitting right in the center, the lower center of the picture. He's kind of balding. He's got long, flowing gray hair. He's a kind of a rotund fellow. He's holding the cane, and he's looking straight at us. James Madison, who's sort of the intellectual luminary of the Constitutional Convention, is whispering in his ear. Everyone's conversing, and Franklin is looking right at us. And they come up with a constitution which creates a structure of government. And sometimes the Articles 1, 2, and 3 of the Constitution have to do with the legislative, the executive, and the judicial branches of government, as they're often referred to. They often think of these as the gears of government. And they're thinking in each one of those articles how to construct the gears, how to have them interact with each other, and then how to get them to move so that the government performs the functions that we want it to perform, to serve us in producing the blessings of liberty and the domestic tranquility and the common defense and all of these things that government's supposed to provide for us, and that it would provide those things for us if they correctly drew from the natural sciences and political science to create a machine that will go of itself, as they said. For them, the energy, the political energy that moved these gears of government would be things like ambition, avarice, the love of fame. These are the passions that would move the gears of government. And irrespective of the intentions of the individuals involved, that because they created the machine right, the outcomes, the function of government would be of benefit to the entire new nation. And it's the common interest that Franklin had with Priestley and with others. For example, those at the University of St. Andrew that led that university to bestow on him an honorary doctorate in 1759. And so there was widespread common interest in these sets of topics between politics and history and nature, and how we can learn from one another in that regard. And of course, it's not just an interest in American politics. They had an interest in the full range of Priestley's new new chart of history, earlier periods of time. And they ask, so what's the evidence that we can use to talk about this? Well, they has the architecture, the buildings, the material culture, all of the artifacts which they used and then left behind for future historians to discover, to use, as well as their written records. Lots of writings. The written record of the human past would be extraordinarily important here as part of the evidence that they would use to talk about these historical periods. That would be true of the ancient periods that Priestley starts off his new chart with. Ancient Rome with Julius Caesar's writings from 2,000 years ago, or ancient Mesopotamia from over 4,000 years ago with its outstanding writings, the Epic of Gilgamesh, one of the great stories of coming of age from the ancient world, or the founding of Egypt. Here, one of the earliest written records we have about the formation of ancient Egypt, where Priestley is that's one of the beginning points for his new chart of history about 4,700 years ago, in integrating Upper and Lower Egypt into this great nation of human civilization. The problem was that once you start getting much before 5,000 years ago or so, the written records start running out. We don't have much evidence of that regard. And so if you want to talk about, well, what's before the beginning that Priestley gave us, well, that evidence starts to not be there. And that was dissatisfying to another historian, Bill McNeill, who's a well-regarded historian from the University of Chicago, writing in the 1960s and other times. He wrote a well-known book on world history. It's not the history of the Earth, about the history of the periods that our planet has gone through. But he's saying, I don't want to start the story with nations and empires. I want to give a human history, humans across the world. And I want to begin in the beginning. So for him, when's the beginning? Now, for him, it doesn't start with the ancient period. It doesn't start with the written record of the past. So when does it begin for Bill McNeill? And he tells us at the very beginning of his book. He says the beginning great landmark of human history was the development of food production. What interested Bill McNeill was agriculture, farming, pastoralism, which he sees as having taken place in the Middle East and in Africa and in Asia and India and the Americas. This was a human accomplishment and was a great accomplishment. If you asked him, well, what happened before the beginning? He had an answer. Well, of course, there was hunting and gathering, but that's not where he wanted to start his story. He starts his story around 10,000 years ago, 8,500 to 7,000 BC. With the development of agriculture. Now and so when he asks the question, how did it all begin? What he's talking about is humanity since the origins of agriculture, and he ties the how to the when question. When did it all begin? And for him, it's around 10,000 years ago that his beginning starts to take place. There are, of course, has been for a long time other ways to define the it of when did it all begin. In addition to nations and empires and humanity since agriculture, we've had people who have been asking, how did the universe, life, plants, animals, humans all begin? But those tended to be answered from within sacred traditions and texts from a range of cultures. Just a few examples might be from ancient Egypt, the goddess of the Nile, the life-giving waters of the Nile in this desert kingdom. The goddess forms humans on this potter's wheel or pedestal in full form. And then Isis, another goddess, touches life into the form, and so we have the how of where did human life come from, and this is part of the ancient Egyptian culture, or in the ancient Maya world from Mesoamerica from around 2,000 years ago. We've got the great story of the Popol Vuh, which is an account of how the cosmos and plants and animals and people are created. And here we've got a mural from the famous Mexican artist Diego Rivera, giving us a representation of this story from the Popol Vuh, which itself is about 2,000 years old. And again, the gods form people out of mud, and then out of wood. Both of those attempts failed, by the way. It wasn't until they made us out of maize, out of corn, that it worked. And so we are the people of corn. But they create them fully formed. So we have the how in these cases. And of course, the very well-known story from Genesis, the biblical book of Genesis, where again, God takes the mud, the dust of the earth, and forms a fully formed human. So in all three of these, we have an explanation of the how, and that the various types of life forms are created in their fully formed versions that we know of right now at the very beginning. And then, of course, famous Michelangelo's painting of God touching life into this now fully formed human. So we had the sacred answers to how the universe, life, and humans began, which has retained its influence for a very long time. It's influenced how we keep time, how we maintain our calendars, and this idea of how it happened and when it happened was interesting. James Ussher, a former bishop of Ireland in the 17th century, accepted the answer of the how question, and then he wanted to know when. And the Bible doesn't give us a date. The Popol Vuh doesn't give us a date. So it required very careful readings of the texts. And from that, he determined that the creation of universe and life and humans and everything started on 6 p.m. into the 22nd of October, 4004 BC. That is years before Christ, because the way that Christians were going to keep time was not with the creation of life, but in the new creation that is with Jesus. And so the calendar starts with the traditional birth date of Christ, and then we are now 2021 years after that. Now the AD and the year of our Lord and the BC before Christ, that's changed. And so we've gone to the Common Era and before the Common Era, or BCE and CE. But we've kept the numbers for convenience. We're used to them. And so the date for our today is advertised as March 30th, 2021, but now 2021 CE rather than AD. That's a time that's pretty much the same in the Jewish calendar. They too read the texts very carefully and determined that we are now in the year currently of 5781. And Maimonides, the great Jewish 12th century intellectual, of course, starts it not in the year of our Lord, obviously, but in the year of the world, Anno Mundi. So if you start with the creation of the universe, with life, of the whole creation story, then counting forward from then, we're at the year 5781. Now, there were people very notably here in Scotland, Sir Charles Lyell, foremost among them, along with others, who also were very interested in the when and the how question, but they looked to other texts, the texts of the rocks, that the rocks were telling us stories. And so the geologists were saying that, you know, what they were learning about the how and the when differed from what had been traditional interpretations of the sacred texts, and gave us a much longer when than the traditional sacred answers to those questions had given us. And the geologists were in conversation with the biologists. And so the famous Charles Darwin writes in his book on the origin of the species, "He who can read Sir Charles Lyell's grand work on the principles of geology, which the future historian will recognize as having produced a revolution in natural science, yet does not admit how incomprehensibly vast have been the past periods of time, may it well close this volume. In other words, Darwin needed more time. He needed to push that when much further back if he was going to explain how we maybe began in that warm little pond, but then had time to evolve, not in fully formed versions as we are now, but in steps to where we are now. Darwin might just have well written that it was not just the future historian would recognize that Lyell had produced a revolution in natural science. Lyell and Darwin together produced a revolution in history, in our understanding of who we are, where we've come from, how we got to be the way that we are. These were brand new explanations that they were reading from the rocks and then later from bones and from blood, from geological and from biological sources. And it redefined what it meant to be human for us. The story changed entirely. It changed even more once people were learning how to read the story that light told us. And then they could have evidence to ask the question, not just about when did nations and empires and agriculture and even the earth and life begin, but when did the universe begin? And to come up with a remarkably precise date for that once the Hubble constant starts getting refined to 13.82 billion years ago. I understand the astronomers are pretty confident that they've got it to plus or minus 80 million years. This is a remarkably precise date for the origin of the universe. And we have now a new chart of history that Priestley couldn't have dreamed for. He didn't have the evidence that enabled him to ask that question. But the astronomers and the astrophysicists and geologists together are able to piece together a history of the universe so that we go from the Big Bang and inflation and quarks and protons, and then atoms with hydrogen and helium, and then gravity bringing them together and causing stars to start the fusion process of all the elements up to iron, and then the supernova and the collisions of neutron stars producing the rest of the elements in the periodic table, and then second generation stars, and not just gaseous planets, but terrestrial planets. So they give us a history. Here's a whole series of its that had to take place before we can start to ask the question that everyone here at NoRCEL is engaged with. And that is, after this creation of the universe 13.82 billion years ago, and then the accretion of the Earth, the geologists tell us, Robert Hazen says he's got it down to 4.672 billion years ago, just over 4.5 billion years ago, a remarkably precise date for that. Now, finally, we can get to having the question of now, when does life, or at least when does life on Earth, since that's the only life we have evidence of so far, how did that begin? When does that begin? Where did it begin? Did it begin in Darwin's warm little ponds? Now we hear that it's maybe probably not in the black smokers, that maybe wouldn't have been conducive to the first life. Was it in geothermal ponds? But where did it begin? Exactly how did it begin? This has been a very tough nut to crack. And we don't even have as precise a date for when this happened as we maybe do for the accretion of the Earth and for the Big Bang. Was it 3.5 billion years ago, 3.8, 4 billion years ago? When was it? And how did it take place? This is what NoRCEL is working on so hard. There's been remarkable progress on that ever since the famous 1952 Miller-Urey experiment. So for 70 years now or whatever, there has been these great advances. But the detective story goes on. And those of us in the stands who are watching it are amazed at the progress that has been made and the persistence of lots of brilliant people trying to sort all of this out. And that's what this conference has been doing. These conversations at the highest levels of scientists talking to each other as they try to sort out this question of how, when, and where did this all begin? Did it begin many times and then catastrophes narrowed it down, and so we just have the last universal common ancestor for all of life on Earth that evolved afterwards? How did this all go about? What's important for me about scientists is, first of all, that they do this heavy lifting, but also that they talk to the rest of us, those of us outside the natural sciences, people who are interested in politics and history and the other humanities and social sciences. And happily, there's a lot of scientists who are willing to do that. People like Martin and Sohan, who invite a political scientist to come and talk to the NoRCEL conference, are among them. We have people like Robert Hazen and Sean Carroll and others who are scientists in their own right and write books for the rest of us on the scientific quest for life's origins, on the origins of life, meaning, and the universe itself, or books by articulate authors about scientists, Michael Marshall, writing about the geniuses and eccentrics on a journey to uncover the origin of life on Earth. These are scientists who realize that they are also public intellectuals, that they are engaging citizens who need to be conversant with what is going on in the natural sciences, that it's not enough for us to leave it to Franklin to have conversed with Priestley, that in our own time, we need to be aware of what the work is that the natural scientists are doing so that the studies of nature and the studies of human nature can learn from each other and can benefit from each other's work. And it's not only the how question of how did all of this happen. It's also, and Addie Pross is another very readable book, a demanding book, but a readable book. How does chemistry become biology? That's the great question that we're still struggling with. It's the definitional question as well, which has been tough to figure out. What is life? If we're trying to explain how did we get there, it would be nice to know what it is we're looking for. And that's not so easy to figure out. There are dozens of credible definitions of life and answers to this question. And so we're left with scientists who are persistent. They're not willing to go beyond the evidence. And they are plotting their way through it very painstakingly. And we are watching as they develop these answers. And it's not just asking what is life. You know, I mean, we've all been turned upside down by this little critter, the coronavirus, as we've gone through this COVID pandemic. Are viruses alive? One biologist doesn't agree, says they're pseudo-alive. And so not only do we have to decide what is life, but now we've got to think about what is pseudo-life and how did we get to either of those and so on. In any case, what you've got then is the whole range of scientists now for many years and decades having worked on these questions and bringing them to the rest of us as the rest of humanity that tries to grapple with what this all means for us. And we've had Eric Chasen is an astronomer, astrophysicist from Harvard. He wrote a book early on, Cosmic Dawn, which he reworked into Epic of Evolution, 7 Ages of the Cosmos. And he starts with the Big Bang, and then he talks about stars and galaxies and second generation stars and terrestrial planets and Earth and life. And then he finishes it up with technological civilization of humanity. He combines these areas. Or Fred Speer, who comes, he starts as a biochemist, but he's interested in anthropology. He wrote a book on culture in Peru. And then he's interested in what this says about this, the redefinition of history, of the study of history, that it's not good enough to stay with Priestley's chart. That made sense in the 18th century. But unfortunately, frankly, a lot of historians, in fact, most history departments at universities that I know of, are still operating within Priestley's chart. They start with about 5,000 years ago with the written record of the human past, and then they go through the different periods of time since then, all of which is fantastic and important material. But the natural scientists have just blown up our sense of the past. It was the geologists and the biologists and the astronomers and the chemists who have said that if history is the study of the past, the written record of the human past is best understood within the natural record of the entire past. And the entire past goes way back before 5,000 years ago. David Christian was trained as a traditional historian. He got his PhD from Oxford on Russian history, one of the great nations. And when he started teaching at the undergraduate level, he was asked to teach Intro to History. And he thought, well, I guess as a historian, I should begin at the beginning. And it is the natural sciences who tell me when the beginning is, as far as we know, the known beginning for which we have evidence. And so he calls his field big history. That history doesn't begin with writing, it begins with the Big Bang, hence the origin of his term. So he's a historian who wants to learn from all of the sciences. He does get up to humanity, but humanity doesn't begin fully formed at the beginning of history. Humanity appears very late in the story, as important as we consider our part to be within that story. So the narrative that he and others have developed say, we have a new chart of history, a chart that Priestley wished he could have had evidence for, but he didn't. But now we do. And so we can begin the story of the past with the Big Bang. That's an it. How did it all begin? With stars and the chemicals of water and the dozens of other chemicals that the astrobiologists explained to us in space. And then we have the next great threshold or transition or step in this development with Earth and our solar system. And then they get to what David Christian calls threshold 5, and others use other terms for that. But the idea of what NoRCEL is working on, and that is life. For us, life on Earth. That's all we know about so far. Maybe we can talk about life on other planets soon, if what Jorge was telling us works out on Mars. But this, and then all of the different developments that took place after we can explain life on Earth. This is one of the ways that we have of talking about big history, and we try to put them together. So the idea of big history is we want to put together these histories, not just of the written record of the past, not just of nations and empires and even humanity, but of cosmos, Earth, life, and humanity. And we're looking to the natural sciences to give us the evidence by which we can construct this great narrative of how did it all begin. And it's a really different story than what we had inherited from previous traditions. So that the traditional historians began a few millennia ago, but we know that if we wanted to talk about the beginning of humans, we have to go back some 300,000 years, but that's nothing. Humans don't begin fully formed at the beginning of the whole story, narrative of the past. So if we have life beginning somewhere around 3.8 billion years ago, we are real Johnny-come-latelys. This is a whole different meaning of what it's the place of humanity in time and who we are. We're very late in the game. The complexities that you have been explaining in the panels over the last 2 days are really mind-boggling. Each one of these issues of metabolism, what has to go into the gaining access and managing energy, membranes, how are membranes formed, and then this incredible reproduction and response to environment. We have each one, the steps to each one of these is complex, and then they have to all fit together. It's no wonder it's taking a bit of time to figure this out. This is incredibly complicated. Maybe it's so complicated that it's only happened here. I mean, maybe we are a fluke. Maybe this is it. And man, we ought to celebrate that we won the cosmic lottery. It's unbelievable that we're here. And this is real cause for celebration. That's one response that we could make to what the difficulties that have gone into the formation of life. But then that we do know somehow, even though it's a little bit unclear yet, exactly how all of this complexity came together and was integrated to form life. But it formed, that much we know. And whether it happened just once or whether it happened many times, but then catastrophes led to just one form surviving and becoming the last universal common ancestor. After that, we have the evolution of a fantastic diversity of life. So we have great complexity going in to that first life form. And then we have a history of incredible complexity coming out of that life form. This moment of the formation of life is just one of the seminal moments of global, maybe universal history. But it is the first form that prokaryote cell, if that's what it was. This was an extraordinary integration of chemical evolution, which we're so impressed by, 3.8 billion years before humans ever show up. Celebration and marvel at this is very often not our responses. When we ask, what does this mean for us? Instead of dancing and celebration, we look at the unlikeliness, it seems like, the fact that maybe we were a fluke, maybe we're it. At least we don't have any evidence yet for other life forms, that if you're interested in life, it's about life on Earth. And we look from the dusty moon, we wondered maybe would there be bacteria there? Well, there's no life on the moon. And we look at the Earth from moon, and the universe doesn't look like it's anything that much nurtures life. We're the lucky ones on Earth where that's possible. We know what happens to anyone who steps out of their spacesuit on the moon, and it's not good. The universe is more apt to destroy life than to nurture it. And so we feel vulnerable and we feel very alone. And we would like there maybe to be some company out there for us, but so far it's pretty much just silence that we're experiencing. And that's been disconcerting to us. Are we alone? And we don't much like being alone. So now we are celebrating just a bit more again with the in just recent decades, with the evidence. We maybe could have suspected that there were other planets, but we didn't have evidence for them. Now we do have evidence for thousands of planets beyond our own solar system. Our solar system is not unique in that. And at least 58 of these are so-called habitable planets. In other words, they have things like the liquid water. It looks like they would have liquid water and the other components that are necessary for life. Maybe it is possible for us to have company out there. And this is just exoplanets in our relatively local area of our own galaxy. And now we can feel confident there's an enormous number of planets out there, many of which must be habitable. So there's a greater sense of optimism, but we don't have any evidence for it yet about if there is life in addition to life on Earth, but there must be. We know now, as Jorge was telling us before, that previous expeditions to Mars have shown us that all of the elements that life uses on Earth are there on the surface of Mars. And there's evidence for there having been liquid water. And if there was liquid water and all the elements, the same laws of nature apply on Mars as they do here. It must be, or at least it could be, that life had evolved on Mars. And if there is the discovery and the current efforts to explore Mars, which Jorge's presentation yesterday was phenomenal. You know, I mean, this is a magnificent project that's going on, one of the main purposes is to determine, was there life on our neighboring planet? If they discover that there was life on Mars, this will be one of the great discoveries of human history, because then we will know, even on our neighboring planet, the closest planet to us, if there was life there as well as here, well, then maybe we can extrapolate from that, and much less then we can think, well, maybe there is life elsewhere on moons around Jupiter or Saturn. And if that's the case, then we should feel confident about that we are not alone, and how nice it would be to think that we have some company. We're a little afraid too. Maybe they'll invade us with infection. So there's that downside possibility, but largely it would come as a great relief. And unfortunately, from one point of view, conditions on Mars changed. And so once again, the universe, rather than having nurtured life, made life just about impossible. We need planets which are habitable, not just for a short time, but for billions of years. If we're going to get from Luca to humanity to that level of complexity, it takes a long time. So they have to stay habitable, and it doesn't look like Mars stayed very nurturing of life for long enough to have that taken place. So if we find evidence of life, it's going to be of microbes. Wouldn't it be fabulous if they found extremophiles that somehow have survived somewhere? But we're not going to find advanced civilizations on Mars like we had maybe thought had existed. If it had remained habitable, maybe those microbes could have evolved into what we consider there had to have been intelligent life, capable of building canals or mounting armed invasions or whatever we were afraid of for a little while. But even if we're not going to find it, we're not looking for that. But if we do find the microbes, and then we can think, if there are exoplanets that have remained habitable, maybe we do have a better chance of finding not just some prokaryote cells, but of intelligent life that we can maybe find evidence of. And so we've been looking for that. The great SETI project, the search for extraterrestrial intelligence, says that it just seems to make sense to us that there must be life and advanced intelligent life out there, which is, emitting radiation, which we can pick up. But as Enrico Fermi asked, well, if it's the case that there is a lot of life out there, where is everybody? Because so far there's no persuasive evidence that there's any intelligent life that we know of. And so far, we haven't picked up on even if there's any life at all. Now, even if the current efforts on Mars don't produce life, and frankly, I hope they do. But the technological, the astronomical, the mathematical skills that are involved in these projects are so tremendous that it strikes me as that that's accomplishment on its own. A couple more meanings before I finish up. One is, very often there's the sense that what this this Luca, this, in one sense, this single origin of life produces is a common origin for all life forms on Earth. And if you put that together with the idea of the Big Bang, this wild idea that all of the universe, all however many hundreds of billions of galaxies there are, starts at one point. Then the entire universe has a common origin. For humanity, the idea that all currently existing humans are descendants of a small band of humans who lived in Africa a few 100,000 years ago. These are three great common origins. And if we could emphasize that, we could say that we actually have a lot in common with each other. If I think that I have something in common with you, maybe I could act more compassionately toward you. I wouldn't see you as completely other. You are so much like me. And so we wonder if one of the important things that we are learning from the origins of life, the chemical evolution of life, is that we are in fact all have common ground in life. Or is it the opposite? There's so much complexity that goes into that first life form. And then immediately there's an evolution of tremendous diversity, fragmentation, separation. After the Big Bang, the universe expands so much that most of it now is beyond our sight, and we'll never be able to interact with it in any meaningful way. And after our common origins in Africa, humanity evolves into all kinds of different cultural groups, which very often are suspicious and hostile towards each other. Is this the story? Unfortunately, it's really one of complexity, fragmentation, separation, and the coming together is what's so hard. But we do know from your research, one of the huge lessons that we have from NoRCEL and the origins of life, the chemical evolution of life research, is that it did not just lead to hostility. We do have bacteria which infect each other. We learned that ants fight with each other, and this happens all the time. But there's something maybe more fundamental than conflict and separation and fragmentation. We know from your work that chemicals did come together. They came together maybe a number of times, maybe just once, but they did come together in a life form. A cell, a prokaryote cell, presumably of some sort, that all of these chemicals had to figure out, if that makes sense, how to work together, to cooperate with each other, to interact with each other so that the cell could perform the functions that it needed to perform in order to survive and reproduce. And that then cells begin this long process of themselves learning how to work together in complex life forms until they get to the point where in us, I think the biologists tell us we have something like 28 trillion cells who are cooperating. The complexity of my being here, of your being there is phenomenal. The numbers of chemicals in each one of our cells and the number of cells in our bodies. And then the interactions between each of us. We make it from particles to persons. And then these persons have been living together in different communities from the beginning in kinship groups for reproductive purposes, in villages and cities and nations and empires. We finally do get to the kinds of things that Priestley was talking about. And sometimes we live together reasonably well. Sometimes we're quite dysfunctional, but many times it does work out well. And so we end up saying perhaps the chemicals can inspire us. Perhaps chemical evolution can inspire us. It can lead to a life form that is my ancestor. I'm alive today because of the life form that chemical evolution produced. I'm very grateful to this. And now that leaves me with the question. Now, and that is, can humanity come together as well as the chemicals did when they first formed life? Is this possible? Now, you haven't completely explained the chemical evolution of life to your own satisfaction yet. You are still working on it. Those of us who are interested in politics are painfully aware that we have not figured out how to bring the complexity of 7.5 billion people together and integrated well enough so that they can work together as well as chemicals do within individual cells and cells do within bodies. We haven't formed the body politic yet. And it takes a long time. It took some tens or hundreds of millions of years to get from Earth to life on Earth. It's took about 3.8 billion years to get from that first life to humanity. Do we have enough time to learn how the persons can work together well enough so that humanity can function in a way that it needs to in order to survive as long as is possible or not? And where can we look for guidance on how to answer this question of, can humanity come together as well as the chemicals did when they first formed the life? Where can we look to for some reasonable answer to this question? Maybe it's not too much to say it's to conferences like what NoRCEL is producing. We have here at this conference people from nations around the world who have come together to share their curiosity, their examinations, to exchange this information so that we can have a better answer to where the life that we so value comes from and how did it originate. Maybe this points to the types of relationships, people who care about what is as true as we can know it in answer to the question about how did we have chemical evolution that provided for life. You care about what's true in answer to that question, as true as we can know it anyway. And you've come together from around the world, from different places, from different disciplines, from different life experiences in order to answer that question. And you're doing this because you passionately care about this topic, about life, and about how life was formed. And now we're asking about what's the it that we want to ask about now? It's not nations and empires and agriculture. And it's not even about villages and cities and nations. Now we're asking about, how can the peaceful, reasonable, sustainable life of humanity begin? So far, it seems as though we've got plenty of polarization and fragmentation and diversity in a sort of a suspicion and a context of hostility. How can we move beyond that? And that if these are the exchanges here, that is a model for what we're doing. Maybe it's not just the chemicals which come together in the first cell. Maybe we can find a way that there are traditions which are developing in which people can come together well enough so that humanity can learn how to survive over the long term. That would be an enormous contribution as well, and would be a contribution not just to chemical evolution, but also to political evolution. And to the degree to which that's a possibility, I will thank you for this conference, and thank you for your patience in listening to a political scientist.